Hi everyone, my name is Anaiya Raisinghani and I'm joined today with Nic Raboy. So this tutorial is going to gently guide you through how to use Docker and Go and connect it to our MongoDB cluster. Check out our previous content produced for synonyms in an Atlas cluster. We're going to be using that today. So stay tuned if you want to learn a little bit about some Gen Z slang and how to integrate Docker and Go. So we're going to start off today with Nic showing us how to use Go on the platform. So take it away, Nic.
Yeah, thanks, Anaiya. So what we're going to be doing first is we're going to be setting ourselves up with a Go application. So we're going to build a simple Go web service. So it's going to be an API. We're just going to have one or two endpoints that communicate with MongoDB. And then we're going to transition it back to Anaiya, and she's going to containerize this thing. So that way you can deploy it very easily with Docker. So you'll notice that I do have the MongoDB Atlas dashboard up. So this is already a cluster that we have deployed. We already have a database and collections. This is from our previous tutorial, which I highly recommend that you take a look at. But just to fill you in, to get you up to speed, we're working with a synonyms data set. We have tweets from Twitter. So we scraped Twitter. We have a series of tweets. We have some synonyms to look at that Gen Z type slang. But really, it's not too important for this example. This is just a high level of the data set that we're going to be using for our API, which is then going to be containerized. So what I'm going to do is I'm going to open up my terminal, and I'm going to go to my desktop. And what I'm going to do is I'm going to create a new directory, and I'm going to call this Go example. I'm going to navigate into it. And I'm going to create a new file, which I'm going to call main.go. So let's go ahead and open that up in our editor of choice. I'm going to be using Visual Studio Code. And you'll notice that my Go application, or my Go file is currently empty. So what we're going to do is we're going to say package main, and I'm going to say function main. So we're just starting it off. So before we actually start writing some code beyond this boilerplate setting up our main function, let's go ahead and download our dependencies, which in this case is going to be the MongoDB Go driver, as well as a toolkit called the Gorilla Web Toolkit, which is going to allow us to use a multiplexer for our HTTP requests. So it's just going to add on to the net HTTP library that already comes with Go, but it's going to make our lives just a little bit easier. So what I'm going to say is go mod init, and I'm going to give it a repo name for this particular Go module's initialization, and I'm going to say github.com/mongodb developer/docker -golang -example. And if you want to see this particular project at the end of the YouTube video, you can actually visit it at this link and download our source code. So I'm going to hit enter. And it created our new Go mod file. Now what we can do is we can add our dependencies. So starting with the MongoDB Go driver, I'm going to say go get, and I'm going to say go.mongodb.org/mongo driver. And what it's doing is it's downloading the latest version of the MongoDB Go driver, and it's adding it as a dependency in our Go mod file. Next up, we need to add the Gorilla Web Toolkit, which we're going to be using for our API. So I'm going to say go get, and I'm going to say github.com/gorilla/mux. And it went ahead and downloaded that as well. So it added both of these dependencies into our Go mod file. So now we can actually start making use of them in our project. So let's go ahead and start populating everything. The first thing that we want to do is maybe say fmt.println, and we're going to say maybe starting the application. And this could be useful when it comes to displaying inside of Docker as well, because if there's a problem, we'll know because it won't actually print out starting the application in that circumstance. So it's a good troubleshooting debug kind of line. I'm going to save it. I do have some Go packages as part of my Visual Studio Code, which is going to do a lot of automatic imports for us. But we'll navigate to the top every once in a while so that way we can see what the import statements look like for each of our lines of code. So next up, what we want to do is we want to establish a connection to MongoDB. And we can do that by first creating a context timeout to be used. So we can say something like context and then cancel equals context dot with timeout. We can say context dot background, and we can give it a timeout time maybe of 10 seconds. So if there's an issue connecting, we're going to automatically time out after 10 seconds. Next up, let's go ahead and defer the cancel. So when the main function ends, we can cancel it. So defer, cancel, just like that. And now we can actually use that context in our connection string to MongoDB. So we can say client, otherwise error, equals mongo.connect. We're going to pass in that context, and we're going to pass in some options to connect to MongoDB. So we're going to say options.client.apply URI, and we're going to say URI string right here. And we're going to get that URI string right now. So I saved it, it added some imports here. Let's go back into the web browser, and let's go to our root page of our MongoDB Atlas, and we're going to say connect. So let's go ahead and say connect your application, and we're going to choose to use Go. We're going to select our version, and we're going to copy this URI string, and we're going to paste it into our Visual Studio Code. So let's go ahead and paste it in. And you'll notice that it's asking for a username and a password. Let's go ahead and create one of those so that way we can use it within our application. So I'm going to go back to my web browser, and I'm going to go to Database Access, and I'm going to say add new database user. I'm going to call this one example. And for the password, I'm going to use password 1234. And for the sake of this demo, what I'm going to do is I'm going to say that I want to read and write only to a particular database. So let's grant specific privileges. So we're going to give it read and write access only to the synonyms database. And we're going to allow for all collections. So we're just going to leave that blank. We're going to create this as a temporary user. So by the time that this video airs, the username and password will have already expired. So that way you can't use our username and password. And I'm going to say add user. So it created an example user with the password 1234, read and write to the synonyms database, all collections within that database. So I'm going to go back into my code. I'm going to use example as the username, and password is going to be password 1234. Now, we're going to be moving this string around as we progress, but for now, let's just leave it there. Because when it comes to Docker, we probably shouldn't hard code this value in our application. So we have our connection. We need to check to see if there's any kind of error. So what we can say is we can say if error not equal to nil, we can say something like maybe panic and then print out the error and it'll stop our application. What we also want to do is we want to try to disconnect from our database when our main function ends. So we could do that through the use of a defer, just like what we did with cancel. And we can say defer function, and we can say if error equals client.disconnect. So if there's an error disconnecting from our database, then we're gonna print it out. We're gonna provide it the same 10-second context we did prior, and we're gonna say error not equal to nil, and we're gonna say panic error. Otherwise, what's gonna happen is this disconnect is gonna be successful, and we will have been disconnected from our database. And we'll add our parentheses there. So this is just setup code for MongoDB. At this point, we should be connected to MongoDB. What we want to do now is we probably want to get a handle of our database and our collection for future use. So we can say something like collection equals client.database synonyms. And then the actual collection that we want to use is going to be called tweets. And we won't touch the slang collection for this example. So we have a handle to our database and collection now. And what we can do is we can actually test it out, make sure that it works. So let's go into our terminal again, and we're going to say go run main.go. And we have an error somewhere. So line 5 and line 8, let's go ahead and check it out. Somehow this appeared on the same line. So let's go ahead and save it. And let's go ahead and try it again. All right, so in this circumstance, it looks like when I hit save, it didn't automatically import my MongoDB dependencies. So we can do a quick fix for this. Go into your Go mod file. Let's go ahead and copy over the line without the version number. We're just going to copy it. We're going to create a new line in here. We're going to paste it in, and we're trying to use Mongo as our class right here. So I'm just going to save it, and it's going to add it. We're going to be using other stuff as well, like options. Let's go ahead and add that as well. And this could usually be fixed by fixing the dependency management system inside of Visual Studio Code or any of your Go plugins. But it's not really a huge deal because we can still correct it. So I saved it. Our errors have gone away. What I'm going to do now is I'm going to say go run main.go again. So it looks like there was an error finding the module again. So it's actually what we want to do is we want to do Mongo/options in there as well. So let's go ahead and clear it. Let's go ahead and say go run main.go. So it looks like it says declare but not used. That's normal because Go likes us to use all of the variables that we declare. Let's just take this and we'll remove it and we'll just add it back in just a second. But we'll say go run main.go. And it says starting the application. And then it terminated because we're not holding it open. So it started it got our handle to the collection, then it just terminated. So far so good. Let's go ahead and add that collection equals in there. Now what we want to worry about is each of our endpoints. We want to get that Gorilla Web Toolkit working, so that way we can actually set up our API. And it's not too much more difficult than what we saw with the MongoDB stuff. So what we can do is we can say something like router equals mux.newRouter. We're going to see if when I hit save, if it imports it for us automatically. It did not, so we can easily get around that by going into our Go mod file, and we're going to copy the Gorilla Mux line, and we're going to paste it in. We're going to save it, and let's see, it should have helped us out here. So router is declared but not used, which is normal. So let's continue. So we have our router. What we can say is we can say http.listen and serve. We're going to provide it a port to listen on. So it's going to be 12345. It's totally up to you what you want that port to be. And we're going to pass in the router. So technically, if I ran it and I remove this collection piece, it would just start serving on port 12345 with no actual endpoints to listen on. So it's just a kind of a generic web application at this point. So now what we want to do is we want to define our API endpoints. So we're going to create two just for the sake of testing things out. But before the HTTP listen and serve line, what we can do is we can say something like router.handle function. We provided a path for our API endpoint. Let's just go ahead and call this one tweets. And the whole thought process here is that we're going to get all tweets from our tweets collection. So probably one of the most simple things that we can do for testing here. So we have the path. We need to define an endpoint function, which we'll do in just a second. And we're going to say methods. And this endpoint is going to be accessible through GET requests only. So let's go ahead and create an endpoint function. I'm going to do that outside of the main. We're just going to leave that blank for now. And what I'm going to do is I'm going to say something along the lines of function get tweets endpoint. The naming convention doesn't really matter. We're going to set up a response. So this is going to be response, and we're going to say http.responseWriter. And we're going to handle the request as well, which is going to be http.request. Now with that tweets endpoint, I'm going to copy it and I'm going to paste it in. So that way, that's the function that gets called every time somebody tries to access this tweets endpoint. So let's do a little bit of cleanup before we progress and actually start populating this function. So for example, if we defined the collection like this inside of the main function, we won't be able to use it inside of our get tweets endpoint. So what we can do is we can make this more of a global variable. So we're going to say something along the lines of var collection, and we're going to say mongo.collection. And if we scroll back down, I'm going to remove the colon there because it's now going to use that global variable. And we can actually use it now wherever we want. So we're going to be able to use it inside of this endpoint function, which we're going to take care of right now. So let's go ahead and give it a shot. So we want this to be an API, and typically an API is going to be returning either XML or JSON data. We're going to stick with JSON for this particular API. So we're going to say response.header.set, and we're going to say the content type of the response is going to be application/JSON. So that way our client, whether that be a web browser, Postman, something else, knows that our response format is going to be JSON. Now, we could technically use a generic document as part of what the MongoDB Go driver offers, but you know what? I, out of personal preference, like to create data structures, custom data structures that are mapped to MongoDB document fields. I think it's a lot cleaner of an approach. So what we can actually do is, outside of the get tweets endpoint, we could say something along the lines of type tweet. So we're defining what each of our documents contains up front rather than having a very flexible BSON document. And it's totally up to you what you want to use. And there's other tutorials that I've written on this subject as well if you want to get an idea of both. But we're going to define the fields that we're interested in. So for example, we're interested in the ID. So we're going to say int64. We're going to say that we're interested in full text, and that's going to be of type string. And to give you an idea of where I'm pulling this information from, if I went into our databases and I went into browse collections and I went into tweets, so I can click edit on this particular document, and it's going to tell us the type of data that we're working with. So for example, I'm going to be using full text, which you'll notice is named slightly different. I'm going to be using the ID. But it gives us an idea of the data types that we're working with. So if I go back into Visual Studio Code, and I want to define the rest of those fields, we're also saying that there's going to be a user, and this is going to be an embedded document, so it's going to be a struct. I'm going to say that this is going to be screen name, and this is going to be type string. And that's it. But right now, this is just a standard Go object. We need to be able to actually map it because if you notice, we were using, for example, full_text inside of our document. So we need to do proper mappings. So for one, let's start with the ID. So for the ID, we need to add a JSON and BSON annotation. So we're going to say BSON, and we're going to say that the field that we want it to map to is going to be _ID. And if it doesn't exist, even though the ID should always exist, we're going to say omit empty. So we're not going to include it in our object for the user to work with. We also want to map it to JSON, so that way we have something for the client to work with. So we're mapping it to BSON, so that way our Go application knows how to communicate with the document fields in MongoDB. And then we're doing JSON, so that way the user knows how to interact with as well. So we're going to say JSON. And for this, what we're going to say is we're just going to keep it the same name. It doesn't have to be the same name, though. So we have those mappings. Let's go ahead and do the same thing. So we have BSON. What we have now is we have full_text. And we're going to say omit empty again. And likewise, we're going to do the same thing for JSON. And for JSON, it's going to be full text. Omit empty. For screen name, let's go ahead and add it again. So BSON. So BSON, let's go ahead and say screen_name because that's what it is in our database. Omit empty. And JSON is going to be, we'll just keep it the same. And you technically don't have to do the JSON and BSON if they're the same name like this because it'll just carry over. But I like to think of it as good practice to define them both. And I notice that I have a typo here. And then we have one more. So this is the actual struct itself. So let's go ahead and say bson. We're going to say that this is going to be user. And just like that, we have something to work with now. So now we can actually work with this tweet data structure like we would any kind of data structure in Go, but we can be confident that it's going to map properly to our MongoDB data. So let's go back into our endpoint function now, and let's start populating that with some useful code. So let's go ahead and say that we want to create a new array or a new slice of tweets. So this is what we're going to hold all of our tweet data for this particular query in. So I'm going to say tweets. This is going to be a slice of tweet. So now that we have our tweets slice, let's go ahead and define our context. And it could be the same context that we used for connecting, or we can create a new one with a new timeout or other criteria. Let's just create a new one with other criteria. We're going to say context. We're going to say underscore here, and we're going to say equals context dot with timeout. And we're not actually using the cancel for this particular function. But we're saying with timeout, we're going to say context.background. And we're going to say maybe instead of 10 seconds, let's go ahead and say 30 seconds as the timeout. So time.second. Now what we can do is we can say cursor. Otherwise, error equals collection.find. We're going to provide that context. And now what we need to do is we need to provide the filter on what documents we actually want returned. Now, since this is the get tweets endpoint and our goal here is to get all tweets from this particular collection, we're going to have an empty filter. And to do that, we're going to say bson.m, so a bson map, and we're going to leave it as empty. Now let's go ahead and check to see if there was any kind of error. So we're going to say if error not equal to nil. So what we want to do is we could say panic, and it would like force quit the application. But that's not really good in terms of an API. We want to be able to relay any kind of error to the user. So what we can do is we can say response.write header. We can provide it what kind of error we want returned. So probably the most generic error that you can return is an internal server error, but it's totally up to you on what makes sense to you. But we're going to say http status internal server error. Now we need a message to go with that particular response code. So that's a response code of 500. What we're going to say is response.write. We need to return a string in this scenario, but since our line 26 says that the client is expecting JSON, let's just return a string with JSON in it. So I'm going to say message. This is just going to be our error message. And let's go ahead and add it. So I'm going to say plus error. Let's go ahead and just return the error string portion, or the message. And let's go ahead and say, let's close that quotation mark, and let's go ahead and add our curly bracket. So this is a string of just JSON here. But you'll notice that it's an error here. It's yelling at us because it's expecting a slice of byte, but we returned a string. And this is easily correctable by wrapping it in a byte, and it should work after that. And it did. The error went away. We're still getting yelled at because we're not using the cursor yet, and we're not using tweets yet. We're going to do that right now. So assuming that we didn't get an error here, the find is successful. The cursor has data, and I actually want to spell it correctly as cursor. But let's go ahead and load all of the results set from the cursor into this tweet slice. And we can do that by saying if error, so we're gonna see if there's an error while we do this, but we're gonna say if error equals cursor.all. We're gonna take all results from that cursor, assuming there's no error when we do that. We're gonna use our same context, which has a 30-second timeout, and we're gonna load it into tweets. Now, if there was an error, then we can basically copy the same code that we did for the previous error. So if error is not equal to nil, let's just copy this, paste it in, because we can still use that, it's still valuable. Let's go ahead and return, so that way we don't continue to execute code on each one of these. And let's now encode our data, because if we made it this far, we've got no errors. Tweets should contain data. And we can say something along the lines of JSON.newEncoder. We can say response. So we're writing we're encoding to the response. And the data that we're encoding is going to be our tweets slice. So it's gonna be JSON encoded, because you'll remember that we had created this JSON attribute. So it's going to know how to map our fields to correct JSON properties. So I'm going to save it, and we're going to take it out for a spin. So we're going to say go run main.go. So it's running the application now. This is just a get endpoint, so I don't need anything fancy to use it. So what I can do is I can go to my web browser. I can go to localhost 12345, and I can say tweets because that's the expected path. And there you go. It returned all of our tweets. It mapped our fields correctly. This omit empty actually doesn't look correct, but we can fix that. But it returned everything. So let's see if we can fix this omit empty, see where we went wrong. So I'll scroll back up to how we've chosen to map. Oh yeah, JSON omit empty. I forgot something there. So I'm going to say user, comma, omit empty. Let's go ahead and restart it. And it should be good at that point. I'm going to refresh it. So we have user and we have screen name. So this is just all of our tweets. We could take it a step further now. I'll do one more endpoint, and then we'll take it over to Anaiya, and she'll containerize this for us for some quick and easy deployments to other microservice infrastructures. Let's go ahead and just what I'm going to do is I'm going to actually copy this endpoint function. I'm going to paste it. This time around, what I'm thinking about naming it is maybe search tweets endpoint. So we're just going to make a slightly different kind of query here. We're still going to return a JSON response. We're still going to be expecting a slice of tweets, but we're going to get other stuff as well. So we're going to expect that the user provide us some kind of term for searching on. So let's go ahead and kind of pull it from our request. So I'm going to say query params equals request.url.query. So now we have access to the query parameters that the user might pass, and they should pass. So the difference with this, instead of a find, which I'll comment out, we're going to do an aggregation pipeline, a very simple one, but we're still going to do an aggregation pipeline. So we're going to create some stages here, and this is going to use Atlas search. So I'm going to say search, I'm going to say stage equals, and this is where we're going to kind of use a generic bson document rather than doing a data structure. So I'm going to say bson.d, and I'm going to say search. I'm going to say bson.d because it's going to be another object. And inside of this, I'm going to say index. I actually do know the index that we used from the prior example, which I encourage you to take a look at. It's called synsearch, is the index that we had created in that prior example. We have a property or a field called text as part of our aggregation pipeline. This is, you can look at the documentation to see all of the available options that you can use. This is going to be bson.d. It's going to expect a query. And that query is going to be query params. And we're going to say get. And let's go ahead and say that the user should be providing us a queue parameter. Now let's go ahead and add a comma there. We're going to provide a path. The path, we're going to search within the full text field. And we're going to be using synonyms. And it's going to use the synonyms from the slang collection, which isn't too important for this particular example, but it was heavily looked at in the prior example. So let's go ahead and add our comma. So go is happy. We're going to add all of our commas here. So we have a single stage here called search stage. Let's go ahead and make use of it. So I'm going to say, what I'm going to say is I'm going to say cursor error equals collection dot aggregate, and I'm going to provide it a context. I'm going to say Mongo dot pipeline for an aggregation pipeline, and I'm going to say search stage, and that should be what we have up there. So it actually shouldn't be. This isn't a function, so we want to use curly brackets, and that's why it's yelling at us. So I'm going to save it. And it's highlighting this because we're not using named, or we're not using keyed fields, which is fine. You could look at the other Go tutorials that I've written in it, and it'll show you how to use named fields if you want to use that. But this is totally acceptable. So we have our one-stage aggregation pipeline. We could remove this comment. If there's an error, we still want to show it. Otherwise, we want to get all results, and we want to return them. So I'm going to save it, and I'm going to go down into our main function, and we're going to add another endpoint to our router. And let's call this one search, and let's say search tweets endpoint. And I'm going to save it. We're going to rerun the application. So go run main.go. So it's running. Let's go back into the web browser. And instead of tweets, let's go ahead and say search. And what I'm going to say next is I'm going to say Q, because that's what it's expecting. And I'm going to say something like maybe slaps. So here we go. It found 2 results based on our search query of slaps. So this used MongoDB Atlas search as part of an aggregation pipeline. And it made use of the example that we saw previous, which was synonym-based search using Generation Z slang words on Twitter. So we do have a functional Go application as of right now. So what we're going to do is we're going to hand it over to Anaiya, and she's going to show us how to containerize this and make it into a Docker container.
Perfect. Thank you so much, Nick. So you guys are in for a treat today. If you've never used Docker before, don't even worry. We're going to ease you into it nice and slowly. First things first, go download Docker from their website, www.docker.com. We'll link it in the description below. So cool. I'm already in our project folder, our Docker Golang example. And the first thing you want to do whenever using Docker is to create a Docker file in your project root, in the root of your project folder. So we're just going to do touch and Docker file. And now let's check if it's there. Perfect. So it's normal to always name your Docker file. You can name it something else, but this is the easiest way to access it. Now we can open it up and then start putting everything we need inside of it. So I'm going to go to my IDE and check it. It's right here. There are multiple ways that you can edit it. You can edit it through your terminal. You can edit it here. I'm going to open up Visual Studio Code though. Okay, so I'm in Visual Studio Code. I'm going to open up my Docker file here and then show you guys the steps on how to create your own Docker file. So open folder. Perfect. So we have our Docker file set up in our IDE, and now we're going to start editing it. So first things first, you want to grab your base image. So grab your base image, and the way that we like to think about Docker files are that you want to build upon an image that's already there, like layers of a cake. And the format that we're going to be running you through is what many Docker files are composed of, but they're super customizable. So first things first, you're going to want your from statement. Since we're doing Go, we're going to use Golang 1.16, and you can also use from scratch if you want to build upon a completely empty image, but since we're using Go, we're going to use Golang. So we start with Golang and we use the tag 1.16 to represent the version of Go that we're going to be using. And whenever you include a tag next to your base image, be sure to set it up just like this. Tags are super important because they hold a lot of very, very valuable information about the base image that you're using, such as different software versions, operating systems, everything like that. So it's really important to include your from statement and then your tag and your base image. Next, we're going to go into what is called the maintainer. Let's see if I can spell this correctly. Okay, I think that looks good. This is actually an optional step, but it's really good practice so that people viewing your Docker file know who created it. So that in this one, you can just add your name. I'm just going to do Anaiya Raisinghani. And then you can also do your email in brackets. I'm going to leave that out for now. Third step is your working directory. So this is super, super crucial to your Docker file since it specifies exactly which working directory you're going to be in. So all of your commands are going to be run through this file. So be super aware of which directory you use. And the way that's set up is just like this. Worker, and we're going to do go src app. Perfect. Next step is just copy. This command allows you to just copy whichever files you want from the specified location on the host machine into a new Docker image. So this is a really important command too. Perfect. And honestly, hard to believe, but we're almost done. Now you're going to have 2 run commands. Run commands are fun because they get to set up exactly what we want to happen at image build time before deploying it as a container. So the first command we have is run go get D and V. This one will actually download all of the Go dependencies listed in the previous go.mod file that was copied into the image. Our second run command is going to be run go build V, and this will build our project into an executable binary file. So now we're actually onto the last step of our Docker file, which is the cmd docker Golang example. Let me make sure that looks good. Perfect. So we're going to make a little edit here. I forgot to include the period afterwards. I just add that in. And this is dependent on if Nic had created his project in a source file. So that you should be doing that, but he hadn't included it. But now you know. And then also line 12 here, Docker Golang example. This can vary depending on what you name it, and this will show up after you run your project. Awesome. So now you have your entire Docker file. It's super customizable. You can add a bunch of different commands here. This is what we're working with. So this last line, line 12, the cmd command, actually defines what is run when the container is deployed rather than when the image is built. So essentially, this command is saying that we want the built Go application to be run when the container is deployed. So this is actually your entire Docker file for this project, which is really cool. Super customizable, super easy to work with, and doesn't take too long to get up and running. Once you have this Docker file set up, you can build and execute your project using your special MongoDB URI link. We're going to go back to Nic really quickly to show you guys where we got our MongoDB URI link from.
All right. So if you remember, we hard-coded this. This was a temporary thing. And generally, you don't want to hard-code this because, one, it does include our username and password. And two, since these are containers, you want them to be able to rapid fire them as microservices, and to have every single one of them configured the same and not very flexible, it's probably not ideal. So we're going to be storing this as an environment variable come time the Docker container. So what we can actually do to accommodate that is we're going to wipe it out, and we're going to pull it from the environment variables from the machine, which in this case would be passed in through the deployment of the Docker container. But we're going to say os.getEnv, and we're going to say, in this case, MongoDB URI. And this is going to be what Anaiya uses when it comes to the environment variable. She's going to be using MongoDB URI in all caps like that. So what we're going to do now is we're going to switch it back over to Anaiya, and she's going to walk us through that process.
Perfect. Thanks so much, Nic. So now we're going to run our container using this long and very tedious URI. Later in this YouTube video, I'll show you guys how to do it a little bit easier, but for now, let's show you guys how to do this one. So first things first, open terminal, back up again. Fantastic. Here we are in our directory. Now we're going to start using the Docker commands. These are pretty simple. They're Docker build and Docker run, which makes it really easy to remember. And so first one, Docker build t Docker, syn image, and then don't forget the period at the end. I always do. I'm gonna have that going. Perfect. And look at that, it's building. Now that it has been built, we're gonna do Docker run. And then remember the port, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For environment, we're gonna do our fun little MongoDB temporary URI. Awesome, let's run that. Perfect, so this is a fantastic example of it failing. The reason why it failed was because I got a little bit too excited, forgot to include some very crucial details. First detail I missed out on was including the MongoDB URI equal sign and then putting my URI. Second reason why it failed was because I didn't have it in quotes. And third reason why it failed was because I totally forgot to include which image we were using. So let me show you how to do it correctly. Go back in and do Docker run, dp, specify the host for 5. Now we have our environment. And now MongoDB URI. Now we can copy in our URI, our temporary URI. Perfect. Quotes there. Now we have Docker syn image, and this should work. Okay, cool. So now I'm going to go to the web browser and test it, make sure it's working. So let's make this a lot bigger. Perfect. And look at that. One of our texts. Let's see if we can change the word. Let's use slaps from before. Beautiful. 10 out of 10, if I may say so myself. Awesome. Okay, so now that we have our container working and we can see how we were able to do it using the entire MongoDB URI link, we want to show you guys how to set up a Docker Compose file. So this just streamlines it. It makes it so that you don't have to use the entire URI link. All you need is this really, really simple command, Docker Compose up. So first thing that we're going to do is set up this file, and you need to first establish a YAML configuration file first. So we can do this by creating a new file in the root of our project folder, naming it Docker Compose, and adding the .yml at the end. So this time I'm going to be creating my Docker Compose file in my ID just because it's a little bit easier. Don't have to go and use terminal and touch, all that stuff. So we're going to do a little Docker compose.yml. Perfect. Now we're in this file. Awesome. So let's run us through what we need first. So first you need to define exactly which version you're going to be using. And the version we decided to use was version 3.9. And you can change this up. We'll link it to below, but there are a bunch of different versions that you can use. It's just normal to use the most recent version. Next, we're going to define which services we're using. So these are also known as containers that you want to be running in your project. And the first service we're going to be using is web. So we've included web since we are attaching to our Atlas Search cluster. The name isn't super important. It acts more like an identifier for that particular service. Next, we want to specify that we are building our application. So after web, we're going to have build. And here we're going to have a little period. Next step, put in your ports information since we are connecting to a ports, and we want our port to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Awesome. Now we're using the MongoDB URI environment. So we need to specify that below with environment. I think that's spelled correctly. I took AP Environmental sciences, still have no idea how to spell it, but let's see if that's correct. And our formatting is a little bit off, so I'm going to include a space right here. Awesome. And then decrease this by 1. Fantastic. And then our MongoDB URI, and we're going to copy in our URI from before. There we go. Perfect. This looks fantastic. So now that we have it, let's save it. So now that we have our URI in, I also just want to go back a little bit and explain why we have to have the period here for build. And this is because it's saying to build upon the Docker file that's in the current folder. Otherwise, you can specify which image you want to build upon. But since we're using our Docker file from before, that's why we have the period there. And so now before I run this, I want to make sure that I kill all of my previous containers. We're going to access Docker Desktop. And I'm just going to go through and delete everything. So now let's try running our file. And we can open terminal back up. Cool. And we're going to say we saved it. So Docker compose up. See if that works. So now we have our container running. So let's check if it actually worked. Especially with this nifty little Docker compose up. So we're going to go back to our browser. Let me make it a little bit bigger for you guys. And we're going to see if we can connect to our Tweets API. So fingers crossed. And it worked. And we have all of our tweets. Thank you guys so much for joining us today. My name is Anaiya Raisinghani, and I'm joined here by Nic Raboy. Today in our tutorial, we went over how to use Docker, how to use Go, and how to combine both of them in MongoDB. For part 1 of our tutorial, be sure to check out our synonyms and Atlas search article on the Developer Hub, and be sure to follow us on our socials. Mine is LinkedIn, Anaiya Raisinghani on LinkedIn.
And I'm just Raboy on LinkedIn.
Perfect. Thank you guys so much. We hope you enjoyed.